Hello students, in the previous class we were doing some miscellaneous examples. So first we will continue with that. Let's go to the next example. That is, the function f is given as 1 comma 1, 2 comma 3, 0 comma minus 1, minus 1 comma minus 3. This function be a linear function from z to z. So we are asked to find the equation f of x. So because it's a linear function, it will be y equal to mx plus c form. We know that x is 1 and y is 1, so we can put that. 1 equal to m plus c. This is equation 1. Now we know that x is 0 and y is minus 1 from here. So we can put y as minus 1 and x as 0 plus c. So c is minus 1. Once you get c, you can put c in this equation, equation 1. So 1 equal to m minus 1 or m equal to 2. So the linear equation y equal to mx plus c, or the function is 2x minus 1. Let's go to the next example. You have to find domain. Given the function is x squared plus 3x plus 5 by x squared minus 5x plus 4. Because this function is having numerator and denominator, especially denominator, so x squared minus 5x plus 4 should not be 0. X minus 4 into x minus 1 should not be 0. X minus 4 should not be 0. X minus 1 should not be 0. X should not be equal to 4 and 1. That means if you want to write domain, you can say that x can be any real number, but not 1 and 4. Let's go to the third question. A piecewise function is given as 1 minus x when x is less than 0, 1 when x is 0, and x plus 1 when x is greater than 0. You have to sketch the graph. So there are actually three pieces: y equal to 1 minus x, y equal to 1, y equal to x plus 1. First, we will put x as 0, y will be 1. But we are not supposed to put x as 0, because the condition is x should be less than 0 for this equation. So you have to put x as minus 1, y will be 2. X as minus 2, y will be 3. So if you draw the graph, we have to mark these points. Next, here x is 0, y is 1. Here x has to be greater than 0. If x is 1, y is 2. If x is 2, y is 3, like that. So we can plot the points. First, I will plot minus 1 comma 2. Minus 1 is here and 2 is here. Minus 1 comma 2. Minus 2 comma 3. So this is here. That means the straight line comes from here till here. But here you can't take 0, so you will put empty circle. Now the next piece, When x is 0, y is 1. So you will put a point. 0, comma 1 is put here. Now the next piece, x is 1, y is 2. And x is 2, y is 3. That means the next part you will draw like this. You can't take x as 0, so open symbol. On the whole, it's a continuous graph. So with this, we have completed the examples. Now we can go to miscellaneous exercise itself. The first question is, the relation f is defined as x squared for x greater than or equal to 0 and less than or equal to 3. Whereas 3x for x greater than or equal to 3, less than or equal to 10. The relation G is given as x squared for x greater than or equal to 0 and less than or equal to 2, and 3x for x greater than or equal to 2, less than or equal to 10. Show that f is a function and g is not a function. First, we will observe f. We will see whether it is a function or not. In the function, suppose if x is 3, then you can take f of x equal to x square and get y as 9. Or you can take f of x equal to 3x and get y as 3. So on the whole, 3 is joined to 9. But in the function g of x, you will take, if you take g of x equal to x square for x equal to 2, then y is 2 square, that is 4. But if you take g of x equal to 3x for x equal to 2, y is 6. That means 2 is joined to 4 as well as 6. Because the x is repeating here, it is not a function. F of x is a function, but g of x is not a function. That is what you have to show. Let's go to second question. F of x is given as x square. You have to find f of 1.1 minus f of 1 by 1.1 minus 1. So f of 1.1 will be 1.1 square. F of 1 will be 1 square. And denominator is 0.1. So numerator you will have 1.21 minus 1 by 0.1 or 0.21 by 0.1 or 2.1. Let's go to question number 3. You have to find the domain. Function given is x squared plus 2x plus 1 by x squared minus 8x plus 2. Because this function has denominator, the main condition is denominator should not be 0. That means x minus 6 into x minus 2 should not be 0. X minus 6 should not be 0, x minus 2 should not be 0. or x should not be equal to 6, x should not be equal to 2. So the domain can be any real number but not 2 and 6. That's the domain of the function. Let's go to question number 4. You have to find the domain as well as range. The function is given as mod of x minus 1. Now, because there is no denominator, no square root, so for x, no restriction. That means domain x can be any real number. But because mod is there, the range can never be negative. It can be 0 or any positive number, but not negative. That is the range. Fifth question. You have to again find domain and range. The function is square root of x minus 1. Because there is square root, the thing which is under the square root has to be either positive or 0 but not negative. That means x has to be greater than or equal to. So the domain is, you can take 1 and greater than 1 up to infinity. Now, range. Because we have y equal to square root of x minus 1. It's a positive square root. So range can be 0 or any other positive number, but never negative. Coming to question number 6. The function f is defined as x comma x squared by 1 plus x squared, where x belongs to set of real numbers. The function is from R to R. You have to find range of the function. So, if you put the values, because x is a real number, when you put x as 0, you will get 0, 0. When you put x as plus or minus 0.5, you will get y as 0.25 by 1.25. That is 25 by 125. 25 ones, 25 fives, 1 by 5. If you put x as plus or minus 1, y will be 1 by 1 plus 1. That is 1 by 2. Next, put x as plus or minus 1.5. Then y will be 2.25 by 3.25 or 225 by 325. 5 fours, 5 fives. 5 6, 5 5s. 5 15s, 5 13s. Here 5 9s. So y will be 9 by 13. If you put x as plus or minus 2, y will be 4 by 1 plus 4, that is 5. Okay, I will remove all these. I will erase. x as plus or minus 3. Y will be 9 by 10. X as plus or minus 4. Y will be 16 by 70. And so on. Because you have to find the range. You can see the y's you can observe. These all y's 0, 1/5, 1 by 2, 9 by 13, 4 by 5. The range or the y's are starting from 0 and going up to 1. 1 is not reached. So, coming close to 1. Starting with 0 and coming close to 1. Less than 1 you can. Next, question number 7. F and G are the functions from R to R. F of x is x plus 1. G of x is 2x minus 3. We have to find f plus g. That is f of x plus g of x. That is x plus 1 plus 2x minus 3 or 3x minus 2. Next we have to find f minus g. That is f of x minus g of x or x plus 1 minus 2x plus 3. That is minus x plus 4. Next is we have to find f by g. That is f of x by g of x. That is equal to x plus 1 by 2x minus. That's it. These are the things which we have to find in this question number 7. Now question number 8 is the function is given as 1, 1, 2, 3, 0, minus 1, minus 1, minus 3. F is the mapping from integers onto integers. F of x is defined as ax plus b. Find a and b. What is a? What is b? So we will take y equal to ax plus b. The first point 1, 1 we will use here. Y is 1, x is 1 plus b. So equation 1. You can take 0, minus 1. So you have minus 1. Y is minus 1, x is 0 equal to b. You can use b equal to minus 1 in this equation. So 1 equal to a minus 1, a equal to 2. So in this way we got a and b, which we are supposed to find. Question number 9. R is a relation from natural numbers to natural numbers. R is having ordered pairs a comma b such that both a and b belongs to set of natural numbers and a is equal to b square. So you have to say true or false. The first one, a comma a belongs to R for all a belongs to. So you have to show that a comma a belongs to R. Suppose if a comma a belongs to R, then A will be equal to A square. But this is not true. This is false. A cannot be equal to A square. Second one, we have to show if A comma B belongs to set of real numbers, implies B comma A also belongs to set of natural numbers. A comma B belongs to set of natural numbers, then B comma A also belongs to set of natural numbers. That we have to show. Suppose if A comma B belongs, then A equal to B square. And if B comma A belongs, B equal to A square. So this is not happening. This can't be true. Both cannot happen at the same time. So this is also false. Next, if A comma B belongs to set of real numbers, B comma C to set of real numbers, then A comma C also belongs to set of real numbers. Or the relation. A comma B is in the relation, B comma C in the relation. So A comma C also should be in the relation. If A comma B is in the relation, then A will be equal to B square. If B comma C is in the relation, B equal to C square. So we will write B square equal to C power 4 and we got A equal to C power 4. We did not get A equal to C square. We did not get this. We got completely different one. A equal to C power 4. So this one is also not true. Next, we will go to question number 10. A is a set having 1, 2, 3, 4. B is another set having 1, 5, 9, 11, 15, 16. F is the function 1, 5, 2, 9, 3, 1, 4, 5, and 2, 11. Now you have to write true or false. The first one is F is a relation from A to B. We will take A to B. F is a relation from A to B. The second one is, okay, first we will see whether it is true or false. 1 is there in A, 5 is there in B. 2 is there in A, 9 is there in B. 3 is in A and 1 is in B. 4 is in A, 5 is in B. 2 is in A and 11 is in B. So this is true. Second one. F is a function from A to B. Here the x's 1, 1, 2, 3, 4. All of them are taken. And then the x's are not repeating. Oh, here x's are repeating 2 and 2. That's why it is not a function. This statement is false. It is relation but not a function. We'll go to the next question, 11th. F be the subset of Z cross Z. F is given as ordered pairs AB, A plus B. For A and B belonging to Z. So this is the set. This is the function. F is a function from Z to Z. Is F a function? Is F a function? That is your question. How will you say whether it is a function or not? We know that a relation from set E to B is a function if every element of set A has unique images in set. So what we will do is we will take the set and in the set A, we will take some numbers of A. That is 2, 6, minus 2, minus 6 in A. Then what will be the function? We are writing the function from A to B, right? To be a function, every element should have unique image. So in A, we are taking 2, 6, minus 2 and minus 6. All these belong to set Z. So if you take 2 and 6 as A and B, so AB 2 into 6, A plus B 2 plus 6. We will have. That is 12, 8. Similarly, if you take minus 2, 6, you will have minus 2 into minus 6 and minus 2, minus 6. That is, you will have 12 and minus 8. So what is happening? X is repeating. That means it is not a function. Let's go to question number 12. A is the set having 9, 10, 11, 12, 13. F is the function from A to N. F of N is the highest prime factor of N. You have to find the range. So you are given A as 9, 10, 11, 12, 13. And F is from A to set of natural numbers. And then F of N is highest prime factor of N. So highest prime factor of 9 is 3. Highest prime factor of 10. Highest prime factors are highest prime factor means 5. Here 3. 2 and 5 are the prime factors. So basically what we are doing is we are writing the prime factors for each element of A. So prime factor of 9, prime factor of 10, 2 and 5, prime factor of 11, just 11, prime factor of 12, 2 and 3, prime factor of 13 is, so if you see highest prime factors 3, 5, 11, and 30. These are the highest prime factors. So if you take range Y, nothing but highest prime factors. That is 3, 5, 11, 30. So in this way, we completed the miscellaneous exercise also. And giving you the summary of this chapter. Quickly, I will put it on the board. First, I am taking the picture. Yeah, almost done. Yes. Whatever you have learned in this chapter, those all I will put it. This is there in your textbook also. You can see from your textbook also. the summary of all the points. One more picture. Which I'll put it here. So you can see this page and this page. We have the summary of this chapter. So with this, we have completed relations and functions also. But we can't go to the KSET part still. That is because you will be learning more about functions and relations in PU2, PU second year. So until you finish that, we can't do KSET questions because in KSET questions, sets, relations, and functions of both PU1 and PU2 are mixed. So we can go to the next topic instead of going to KSET. We can go to the third chapter. And the third chapter is trigonometric functions. So today let us do or just go for introduction with trigonometric functions. First we will start with angles. What are angles? Suppose if you have a point, let us name it as O and let us call it as vertex. Then we have a straight line or a ray. This is called initial site. If you rotate this line or ray up to some extent until here and stop, that means the line came here and stopped. But because it stopped, this is called terminal site. Name this line initial side as OA and the terminal side as OB. So, how much we have rotated? If you measure this, how much the line is rotated, that will give you angle. And because we are rotating or we are measuring in anti-clockwise direction, this angle will be the angle you can denote by theta. So this angle theta will be positive because we are rotating in anti-clockwise direction. On the other hand, if the vertex is here and OA initial side is here. Suppose this initial side is rotated up to some extent and stop here. So this is OB, the terminal side. And then the measure of how much rotation we have done is angle. But here we are rotating in clockwise direction. That's why the angle theta here is negative when you measure. Now, next page. If I take the vertex O here and the line OA, that is initial side here. And if I start rotating this line and make one complete revolution, here one complete revolution, we did not stop in the middle. We have rotated for one complete rotation. Then I stopped it. So the initial side is only the terminal side. Both the initial side and the terminal side are same. Now I said angle is measure of rotation. So how will you measure this rotation? How much rotation? Angle can be measured using degrees, using radians. There is one measure called degree measure. There is a second measure called radians measure. So we will be learning only two measures. Actually, there is another measure, that is grades also. But you will not be learning. So first, if you go to degree measure, if you learn about degree measure, as I told you, this is O, the vertex. This is initial side, OA. If I make one complete revolution, that measure is taken as 360 degrees. So here the angle theta is 360 degrees. But instead of making one complete rotation, if you take the vertex and the initial side OA, if you rotate half the way, only half revolution, then this will be the terminal side OB. Because it is half of 360 degrees, the angle here is 180 degrees. And now, if I take the vertex O here and the initial side OA, this time I am not rotating complete or half, but I will rotate quarter and stop here. That means the terminal side OB is here. Because it is quarter of 360 is 90 degrees. So here the angle will be 90 degrees. Similarly, if I take O, the vertex here, and the initial side OA here, this time I'm rotating quarter, then half, then 3/4 and rotating. That means the terminal side OB is here. So 3/4 means 3 into 90, that is 270 degrees. So this is degree measure. But one full revolution, as we have taken as 360 degrees, what will be 1 degree? It will be 1 by 360th of a revolution. That means You have to take one complete revolution and divide it into 360 parts. Like this complete revolution, you will divide it into 360 parts. So each part will be 1D. That is the meaning of it. I will show you this in the protractor. Protractor is the best way to show this. Let me show you. I will paste this one on the screen. I will paste this protractor. On the next page. One second, it is not getting pasted. Yes. Now it got pasted. See, the revolution is starting from here. In this diagram, the revolution is starting at 0. And I am making one complete revolution from here to here. This I have divided into 360 parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 20, 30, 40, 50, 60, like that up to 180. Until here, 180. If you start from here, then also you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140, 150, 160, like that. 310, 320, 330, 340, 350, 360 parts. If you take each part, like if you take this part which I have colored, this represents 1 degree. So 1 degree angle, if you want to draw, you will take this as vertex, this as OA, initial side, and 1 degree means till here. It's a very small angle. So this angle theta will be 1 degree. Out of 360 parts, I am taking one part. That is what I told you. Out of 360 parts, if you take one part, that will be considered as 1 degree. Now, if you zoom this 1 degree, suppose I am taking 1 degree angle here. I am zooming it. 1 degree will not be this much big, but I'm zooming it. So this 1 degree, I'm dividing it into 60 parts. 1, 2, 3, 4, 5, 6, 7, 8, like that, dividing into 60 parts. Each part, that means if I draw a small angle here, this angle, each part, the small part, that will be 1 minute. So 1 degree is divided into 60 minutes, 60 parts. And 1 minute will be, out of these 60 parts, if you take one part, 1 by 60th of a degree, that is 1 minute. Now, if I take this 1 minute angle and zoom it, suppose this is vertex, this is initial side, I'm zooming it. This angle is looking too big, but it is 1 minute. Initially, I took 1 degree. Now I am taking 1 minute. Okay. So this 1 minute angle, again I am dividing it into 60 parts. So each part, that means this angle, this small angle, will represent 1 second. So 1 minute is divided into 60 seconds. So 1 second will be 1 by 60th of a minute. If you won't zoom, you can't see. Now, as we have positive angles, we will have negative angles also. You can have minus 30 degrees, minus 420 degrees. How will you do that? You will take vertex, initial side, and rotate this angle for 30 degrees in clockwise direction. So this angle will be minus 30 degrees. How will you have minus 420 degrees? You take this initial side, rotate in clockwise direction. From here you make 360. Until here, one complete revolution, 360. Rotate it more by 60 degrees. Then stop here. This angle will be minus 420. If you want to show 420 degrees, you will take the vertex, initial side OA, you will make one complete revolution 360 degrees, again 60 degrees extra. That means the angle will be here, the terminal side will be, and this angle will be 420 degrees. Any angle, you can draw it easily with the help of protractor. There is another measure for angle, that is radian measure. Radian measure will be little bit difficult, but you can learn it. First of all, you have to see what is 1 radian. How will you measure 1 radian? For that, take a point O with radius 1 unit. 1 unit means 1 inch, 1 centimeter, 1 meter, 1 kilometer, anything. And draw a circle. Now, measure the length of the arc This is the arc. Arc measure also should be 1 unit. Draw the radius again here, 1 unit. So this measure will be 1 radian. If it is minus 1 radian, how will you draw minus 1 radian? The same measure but in clockwise direction. You will take 1 unit arc in the clockwise direction. This will be minus 1 radian. How will you draw 1.5 radian? You will take center O, again radius 1 unit, and again you will draw a circle. So if you take 1.5 unit arc, 1.5, not 1, the length of the arc is 1.5. Then if you take again one more radius here, 1 unit, this measure will be 1.5 radians. Minus 1.5 radians, it will be in same measure but in clockwise direction. Clockwise direction, you have to take arc of length 1.5 unit. This is the radius of 1 unit. So here the angle will be minus 1.5 radians. Now, if you take O vertex and initial side A and complete one revolution, that is taken as 2 pi radians. So suppose if you make only half revolution, that will be pi radians. If you make 1/4 revolution, that will be pi by 2 radians. If you make 3/4 of the revolution, that will be 3 pi by 2 radians. As we have learned in degree measure, like that. Now, later on, you may use some formulas related to geometry. In a circle with center O and radius R, if the length of the arc is L, this is the sector. L is length of arc. R is radius. Theta is angle in the sector, and this is sector. So one formula you have is length of the arc is r theta. Area of the sector is half r square. This is area of sector formula. These two formulas you have learned in geometry, but in this lesson also you may use it. So we will conclude this topic in the next class. We will do some examples and exercise 3.1 also. At present, we will end the class.